Hello everyone, good morning. Myself Muralidhar Reddy. I'm a DevOps consultant and solution architect. Now we are going to discussing about end-to-end cloud migration plan from on-premise to AWS. In this video, I'm going to show you what are the steps involved when we are doing that on-premise to AWS migration part. Okay. So for that one, here we have a AWS zero to hero or GitHub repository, and then here I have created one folder on-premise to AWS, and here I have written that README file as well. We can go with one by one so that you will get some idea. And here you can see the README file. Just click this one. And before going to discussing this migration plan, first we can understand one thing. Let's take an example. Okay, you are working one of the organization. There we have a multiple environments running in the on-premises. Now they are planning to migrate few of the applications and databases from on-premise to AWS. Now, example, existing on-premises or environments, example, dev, test, QA, UAT, pre-prod, prod. These are the environments available in the on-premises. And also applications and databases needs to be migrated. Those are 10 microservices, 4 monolithic applications, and 5 MySQL databases. So these are the things, these are the applications, both monolithic and microservices and also databases needs to be migrated. So what is the plan of action? How do we do everything? We can go through it so that you will get some idea. And remember guys, one of the most important in interview level also, have you worked on migration part? So once you done this, watch this video, complete this video, right? You will get some idea. Okay, this is the way of we'll be do that migration from on-premises to AWS side. Okay, first of all, I have divided 4 phases. Phase 1, right? Planning and preparation. Remember, when you get any migration part, right? Directly it won't come to our team. First, how it will come? First, they will be discussing who? VP or Director of Development and DevOps or QA team. Initially, they will be discussing that particular migration project related one. When are we going to migrate this particular application? When can we start that particular application? Example, migration. Example, every quarter 1 or quarter 2, quarter 3 or quarter 4. When can we start that particular one? Initially, they will do the discussion. Once that discussion is completed, step 2 is informing managers. They will be informed to the managers. Just they will give the heads up like, hey, our new project is coming that is related to migration from on-premises to cloud. That is the example AWS. Okay, once they will be informed, right, what they will do, right? Example, in the managers or architect level, right, each individual teams, example, development, okay, QA team, DevOps team, the particular managers and architects, they will be discussing necessary actions required for this particular migration. Once this particular step 3 is completed, right, respective managers or architects inform to their respective teams. They will give the heads up like, hey, we are going to do the migration next quarter 2 or quarter 1 or next month, or depends on that discussion part. Okay, and here you have to remember guys, usually example, if you are working one of the organization, there we have a DevOps team. Example I'm telling. Okay, if we have 15 members in the DevOps team, 15 members, they won't be work for migration. So here manager or team lead will decide who is going to involve this particular migration project. Okay, so they will be assigned few of the team members who will be going to involve in this particular migration. Okay, step 4 is completed, right? Then step 5 here is one of the most important. Usually any organization, okay, when they are doing that any migration or they are doing any new project, right, usually they will be assigned one scrum master. Okay, what scrum master will do, right? They will be scheduling that migration meetings and also tracking updates, what is going on, or do we have any blockers, how is going on, everything. They'll be track the status updates as well, and also managing the migration related activities. And also let's take example, you are a DevOps engineer. Okay, you need someone help from other team. So you can inform to Scrum Master. So Scrum Master will reach out to them to schedule the call. Okay, during that call, whatever you have a questions, you can ask them also. So these are the major Scrum Master responsibilities. And also when we are doing that cutover plan also, during that time, Scrum Master will be note down everything step-by-step process, who is going to do, what is going, how much time it took, everything he or she will be note down all the data. Okay, understand, right? Fine. Now, once step 5 is completed, step 6. Here we have a dev team and DevOps team and QA team. Just they will be discussing about the migration process in detail. What are the applications going to migrate, everything. And once step 6 is completed, step 7. This is the one of the most important. They will be prepare the application inventory. Okay, they will be create one Excel sheet. There they will be mentioned that what are the applications, databases, what are the dependencies, along with any dependencies, everything they will be defining in that particular Excel sheet. Example, as I said earlier, 10 microservices, 4 monolithic applications, 5 MySQL databases, and also other dependencies, if any, they will be decide. I mean, everything they will be mentioned in the Excel sheet. Once everything is defined in the Excel sheet, right? Step 8, one of the most important, they will be review that Excel sheet. Okay, depends on that one. They will be assigned a specific engineer or specific teams. Example, for microservices, if you want to be deploy microservice in cloud, right? We can use either ECS or EKS. So ECS or EKS will be taken care by DevOps team, right? In the particular Excel sheet, they will be mentioned the DevOps team. Similarly, all the whatever mentioned that Excel sheet, we will be reviewed and we'll be assigned that who will be going to taking care, whether it is DevOps team, whether it is going to taking care by developer, or whether it is going to taking care by QA team. Okay, fine, clear, right? Next one, step 9. One of the most important, Jira or Rally ticket creation. Remember one thing, guys. Majority of the organizations ticketing tool, either Jira or Rally will be used. So this particular depends on this Excel sheet discussion, right? Either DevOps manager or Scrum Master will create the tickets in the Jira or Rally, so assigned to the specific team members. Example, networking related setup taken care by Murli. Okay, example I'm telling. Understand, right? E-case related taking care by Suresh, Naresh, whatever, whoever. Okay, fine. And also daily internal meetings also will be there. Example, DevOps team, they're having internal meeting discussion and to track the what is going on. What are the, do we have any blocker? Everything will be discussing. Similar to for QA and also development team also, they will be having separate internal calls and to track our progress as well. And also Scrum Master. Scrum Master also will be set up the daily and bi-weekly migration meetings to monitor progresses. Remember, once this particular completer, right, tickets is everything clear, created everything, right? So Scrum Master also will be scheduled the call, depends on project to project. We may have every day or every 2 days or 3 days once. Okay, we'll be having that meetings. There we have to give the status of the particular project. Understand, right? This is the planning and preparation. Any questions now? In the planning and preparation, any questions? Understood, right? Now, one of the most important, once planning preparation is completed and we have prepared that Excel sheet, there we have mentioned that what are the applications, databases, everything going on. Now we need to decide cloud migration strategy. What type of strategy we are going to be implement? Usually we have 6 type of strategies. That's why 6 R's. Okay, one by one we can discuss. First one is left and shift. Left and shift is nothing but rehost. Rehost is nothing but, let's take an example. You have application in the on-premise. Just what we'll do, right? Same. We won't be doing any modification without modifying anything, right? Just we'll be deploying. We will be deploying to the cloud. Okay. Example: when to use quick migration, legacy systems, when minimal changes is required. Okay. For example, managing a virtual machine from on-premise to AWS EC2 without altering the application. We don't require to modify anything. Just will be left and shift. Okay, we'll be do that. This is one of the strategy. And second one is re-platform. Re-platform is nothing but left, tinker, and shift, or re-platform. What it will do, right? Move to the cloud with minor optimization to take advantage of cloud native capabilities. Usually this re-platform when will be used to improve performance or cost wise. When small changes are feasible, during that time we'll be use this particular re-platform. Example, migrating app to the AWS EC2 and replacing the local database with Amazon RDS. Example, in on-premises, right, we are using that local database. Okay, inside the EC2 instance, we have installed. Instead of that one, what you can do, right? We can use that AWS RDS managed one. Okay, this is one of the strategy. Okay, cloud migration strategy, re-platform. Third one, right? Refactor or re-architect. Example, some of the organizations, they may use monolithic application. They wanted to segregate to microservices. So during that time, we'll be use the re-architect or refactor So these are one of the things. Okay. Understand it? When to use, especially this for scalability, agility, and long-term cost saving, and also to adapt microservices and also containers level. If you want to be do the serverless architecture, during that time we'll be use this particular refactor or re-architect. And retire. Retire is nothing but example, some of the application we are not using much in the on-premises. Then what we'll do, right? We'll be deprecate. It means we'll be shut down that particular old internal reporting tools that no longer use. Those things will be remove. I mean, shut down that. It means we'll be delete this particular application in the on-premises. This is a retire. And retain. Retain is nothing but like keep certain applications on-premises or delay migration. Some of the application will be keep in on-premises only, and also we example when to use those complaints or regularity concerns, and also low priority applications, and also system not yet ready for migration. Those things will be keep it in the on-premises only. Example, some of the example, right? If you are retaining an ERP system that requires on-premise hosting due to licensing constraints. If you have any licensing constraints also, will be temporarily will be keep it in the on-premises only. Later we will be migrate those applications as well. Okay, understand, right? Next one, repurchase. Repurchase is nothing but example, some of the organization, if they are using self-managed, self-hosted CRM, instead of using self-hosted CRM, right? What we can use SaaS applications, either Salesforce or Microsoft 365. Those things will be use it. So these are the 6 strategies. Depends on our requirement. We'll be decide whether we'll go with rehost, okay, left and shift, or refactor, or re-architect, or re-platform. Okay, depends on that. We'll be take the decision. Understand that? This is the cloud strategy. Total, we have 6 strategies available. Depends on our use cases. We'll be take the decision. Especially when you are doing the migration, right? During that time, we'll be use that left and shift only initially. Later, once everything's done, later, if you want, we can convert that microservices. Once all applications, all the environments, applications are moved to AWS, later will be decide that to convert that microservices if you want. That is usually will be follow. But depends on project to project. They may, before going to migrate also, they may convert that microservices as well. That is totally depends on project, guys. Okay, clear, right? Fine. Phase 1 is completed, and also cloud strategy is also completed. What is the next one? Next one is we need to create the infrastructure setup. So we have decided these are the applications, these are the databases, and these are the microservices, monolithic applications we are planning to migrate. And we have prepared that Excel sheet, and also we have created that particular tickets as well, everything ready. Now, phase 2, right? We'll be create the infrastructure setup. So here, in case infrastructure team, if we have any architect, right? He or she will be create that architecture. So depends on that particular architecture, we'll be implement one by one. Okay. Step 10 is architecture design. Once architecture design is completed, then we'll go with task execution begins. As a DevOps engineer, we'll be start one by one. Example, if you want to be migrate from on-prem to cloud, right? So first thing is you need to create the networking. We'll be create the network. And also we need to set up the connectivity between cloud to AWS. We'll be do that one by one. We'll be start that one by one as a priority base. Okay, task based priority. We'll be do that. And here you have to remember, if you are doing first time, if you are doing migration from on-premise to cloud first time, right? What you have to do, you need to create the AWS accounts. Step 12 is you need to create the AWS account. Remember one thing, if you already having the AWS accounts, right, we can ignore this one. But I'm telling that from scratch, in case if you are doing the migration first time from on-premises to AWS, so this is the process. Now here, if you don't have any AWS accounts, right, what we'll do, right, we will be create the AWS accounts. And here depends on use cases, right, depends on project. If we have a different environments, right, as I said, dev, test, QA, UAT, pre-prod, prod, and infra, right? So each individual environment will be having the separate AWS account, or if for the lower environments will be maintain the single AWS account, and for production, pre-prod, and the infrastructure related one will be maintain the separate AWS accounts. This is totally depends on project to project, whether they wanted to maintain the separate AWS account for each environment, or all the lower environment will be maintained that a single AWS account. For production, pre-prod, and infrastructure related account will be having the separate one. Understand, right? Any question this one? Account creation, fine. And one more thing, remember, if you are creating first time AWS account, usually we'll be reach out to AWS team. We'll be having that AWS team managers. We'll be connect with them and we'll get that some info from them. And do we have any, if you migrate from on-prem to cloud, are you guys going to give any discounts? Everything will be discussed with them. Usually they will give the discount when we are doing that migration. So initially we'll be connect with them as well. Understand, right? Fine. What is the next one? Networking. As I said earlier, first step is we need to set up the networking. Step 13 is networking. Here, as a DevOps engineer, you need to create the VPC, subnet, route table, internet gateway, NAT gateway, NACL, everything. And also, if you are using multiple VPCs, right, each and every environment, we may use the transit gateway, transit VPC, cloud WAN, or VPC peering. We need to set up everything. So here, example, if you see here, these are the CAD ranges. Dev CAD range is 10.20, 10.30, 40, 50, 60, 70. And remember one thing, whenever you are creating any networking related one, I highly recommend we always go with the Terraform script. We'll be write the Terraform script and then we'll be create the infrastructure. And one more thing you have to remember, guys, here, when you are choosing the CAD ranges, this particular AWS CAD ranges and also your on-premises CAD range, both should be different. If it is the same, right, we don't have any option to set up the connectivity between. Connectivity means connectivity between your AWS and cloud. It won't be supported if you have a same CAD range. That's why first you need to work with on-prem team, networking team. We need to get that information. What are the CAD ranges you guys are using? So once get that particular information, then in AWS side, we'll be decide what is the CAD range we are going to be using. Again, I'm repeating, please don't use same CAD range as on-premises. If you use that one, we don't have any possibility to set up the connectivity. Again, you need to be recreate everything, entire infrastructure you need to recreate. Understand, right? Any questions? Okay. Step 13 is completed. Awesome. Now, what is the next one? Networking is completed. Now, what you have to do? You need to set up the site-to-site VPN between your AWS and on-premises. The reason, right? Now you need to migrate your data, database related data from on-prem to cloud, right? What you have to do? You need to set up the connectivity. Then only you can able to migrate the data from on-premise to cloud. Okay, understand, right? So for that one, right, you need to work with on-premises networking team, and they will give the public IP, and we need to set up the site-to-site VPN. Once it is done, and we need to test the connectivity, whether it is working as we expected or not, whether connection is happening between cloud and on-prem or not. We need to be test it everything. Okay, and here also wherever it is applicable, highly recommend to use the Terraform script to create the infrastructure, set up the infrastructure. Usually in real time, for VPC and site-to-site VPN, everything, right? We always go with the Terraform script only. Understand, right? And next to step 15. This is one of the most important. Either we can use client VPN, AWS client VPN, or Cisco VPN. Depends on project to project. They may use either client VPN or Cisco VPN. Why do we require this particular one? Let's take an example in AWS side. I have created the servers in the database in the private network. You can't directly connect, right? What you can do, you can connect using Jump server. You have to log into the one of the server, and from there you can connect the particular DB servers or whatever. But in case if you want to connect from your system, right, what you can do, we can set up the client VPN and we can set up that particular client VPN in your system. Once you connect the client VPN, you can able to access your internal applications. Example, I'm telling here, we can see that user-registration-dev.techworldwithmurali.in or .com. This particular URL, this is the internal one, because dev is the internal one, right? If you want to be accessed, right, either you need to connect the client VPN or Cisco VPN, whatever, depends on project to project, we'll be use it. Understand, right? We'll be set up this particular client VPN or Cisco VPN. Clear. And mostly, right, if you use that AWS, most of the project they will be use the AWS client VPN, but AWS client VPN little bit cost wise very high only, but still even if it is a cost wise high also, we'll be use this particular one. Okay, clear. Any questions now? Fine. Now step 16. Here most important, DevOps tools installation in infra VPC. As I said earlier videos as well, usually all the DevOps related tools, example Jenkins, SonarQube, Nexus, JFrog, okay, yeah, SonarQube, everything, right, will be installed in the separate VPC. Why? Usually, instead of each and every environment installing that Jenkins, SonarQube, everything, right? What you can will be create the separate infra VPC. There will be install the particular DevOps tools. From the particular infra VPC, will be set up the connectivity between dev to infra, QA to infra, test to infra, okay, UAT to infra, pre-prod to infra, production to infra. Will be set up the communication. Now what will happen, right? When you run the Jenkins job, if you want to be deploying the production, we'll be having the already having that connectivity. And then if when you trigger the job, we will be set up that assume role concept. We will be connect the particular one specific account, which will be deployed automatically to the destination accounts. Okay, understand that? And here you can see that example, Jenkins, JFrog, SonarQube. These are the URLs, jenkins.techworldwithmurali.in, sonarqube.techworldwithmurali.in, artifactory.techworldwithmurali.in, everything. And here also remember one thing, usually very long back, we were installing this Jenkins, JFrog, SonarQube in the EC2 instances. But when it comes to the reality in the real time, right, we always install in the EKS cluster, okay, for better scalability. Understand, right? So here we'll be use that Helm concept. We'll be use the Helm concept. Using Helm, we will be install it. In case if you are not aware, how do we do? In our DevOps hands-on project, I already covered that how do we install all the DevOps tools using Helm chart. Please have a look so that you will get some idea in techworldwithmurali.com website. Okay, clear, super. So these internal tools, Jenkins, everything's ready. Now what you have to do? Step 17. In step 17, right? For monolithic microservice applications, either we can deploy in the ECS or EKS setup for microservice applications via Terraform. Here you have to remember, depends on application architecture and also team's discussion will be decide whether we'll be go with ECS or EKS. Example, if you go with EKS, right, we'll be create the EKS cluster using Terraform, everything will be done that, and also will be integrated with Jenkins, everything will be do that one. Okay, this one also will be write the Terraform script and then we'll be provision the infrastructure. EKS cluster. Example I'm telling EKS cluster. That is depends on architecture and the team discussion will be decided. Usually 90% of the organizations, right, they will be use that EKS cluster only. The EKS cluster having a little bit more flexibility compared to ECS. Okay, clear. Now coming to the step 18 for monolithic applications, right? Example, if you want to be monolithic applications, we will be deploying the Tomcat. Okay, for that one also we need to be prepared, right? For that one we'll be write the Terraform script. What Terraform script will do, right? It will automatically create the auto scaling group, application load balancer, and also it will create the Route 53 record, and also it will update that load balancer. Everything will be write this particular monolithic application, and also application will be deployed in the EC2, whether it is Windows or Linux EC2 instance inside the Tomcat web apps folder. Everything will be defined that particular condition in this particular one. Monolithic applications related one also will be prepared that particular one via Terraform. Okay, clear, super. Now, what is the next one? Step 19. This is also one of the most important. Some of the organization, they may use Cloudflare, okay, GoDaddy, their domains is available there. So in case if you are using AWS, right, we are migrating. So they may also decide that we can go with AWS related one, hosted zones. We'll be create the hosted zone and we'll be migrated all the records to the particular Route 53 hosted zones. This is also totally depends on project to project. Or once migration is completed, later they may decide this particular Route 53 creation and they will be migrate all the DNS. That is totally depends on our requirement. Will be flow this one. Sometimes this is optional as well. Clear, right? Fine. And coming to the step 20, this is one of the most important. Coming to the database setup. So when you are migrating application, as I said, microservices, monolithic applications, and the database. In on-premises, as I said, we have a MySQL. So now what you have to do, we need to migrate that MySQL from on-prem to cloud. In cloud, right, if you go with the RDS, we can use RDS MySQL. So example, we are going with RDS MySQL. So as a DevOps engineer, you need to set up the RDS MySQL cluster. Once it is done, everything's done. Now what you have to do, we need to inform to DBA team. DBA team will taking care remaining part. As a DevOps engineer, our responsibility is using Terraform or using CloudFormation, whatever. Okay, especially current most trending part is Terraform. Using Terraform, we'll be create the infrastructure. Once creation completed, infrastructure creation is completed, that particular RDS MySQL cluster is completed, will be informed to DBA team. DBA team will be taking care further steps. What DBA team will do? The next step, database migration. This particular database migration part, step 21. Okay, this particular step 21 taking care by DBA team, not the DevOps team. Okay, for migrating from on-premise to cloud, right? They may use either AWS DMS, database migration service, or they may use log shipping, and also they may have other database replication techniques. They will be follow that. They will be migrate from on-prem to cloud, and they will be set up the sync as well. Okay, from on-prem to cloud as well, replication. Understand, right? Fine. As I said, right, responsibility, DBA team will handle the migration process related to database migration, database related migration. Okay, once this is completed, they will be informed to Scrum Master, hey, DB migration also done, and we set up that replication as well. When the data is stored in the on-premise, automatically it will be replicated to cloud as well. Everything is done. They will be done that one. Okay, clear, fine. Now final step in the infrastructure setup, right? Step 21. In step 21, infrastructure setup completion notification. Once it is done, right, we'll be informed to Scrum Master, development, and QA team about this one. Hey, we have done that, infrastructure setup is completed, either in terms of monolithic application, microservices, and also DBA team also migration, the particular data also sync is set up, and the replication is happening continuously. Everything is done. And also we need to update all the respective Jira or Rally tickets, and we need to update that accordingly, and we need to close that so that once Scrum Master will see that, they will also understand, okay, DevOps side, we don't have any pending parts. Okay, and final checklist also need to be reviewed. Example, networking related, VPN connection related, DevOps tools, example, Jenkins, SonarQube, Nexus, whether install or not, JFrog, and databases are provisioned accessible or not, whether migrated, the data sync is set up or not. Okay, and also Route 53, if you have any Route 50 records are migrated or not, everything we need to be checked. Okay, and also we need to create the documentation. Once setup is completed, everything simultaneously we need to create the documentation, and also if you have any architecture diagram also we need to update, and also if you have any credentials we need to update the credentials. Please don't store it in the we need to store it in the either, example, in AWS, right? We can use secret manager or parameter store. There we can store that particular credentials. Okay, be careful, credentials are, we need to be stored securely. Okay, and also confidence space and zero, whatever. Okay, everything done, right? This is the step 21. Any questions now? Now, so far we have discussed, one is planning and preparation, and infrastructure setup is completed. Now, what is the step 3? It means phase 3. When it comes to the phase 3, right, here development team preparation. Now, develop team, they will do the necessary changes for the build and deployment purpose, the particular applications. And first, what they will do, right, they will build the application. They will build the application using Jenkins job. Example, if it is a monolithic application, okay, if it is a monolithic applications, okay, if it is a microservice applications, we'll be create the Docker image and we'll be push it either is Docker Hub or JFrog, Docker Hub or ECR. And if it is a monolithic applications, if you are deploying the Tomcat, we'll be generate the jar or war file, whatever, okay, will be created. And the next one is deployment of microservices and monolithic applications. Now, example, I'm taking dev environment. Okay, developers deploy microservice in dev environment using Jenkins job. After deployment is done, right, what will happen? If it is not created the load balancer, it will create. If it is already created the load balancer, existing load balancer, it will be automatically create the listeners, and it will automatically update the create the route 53 records as well using AWS Ingress controller, and also external DNS automatically create the records. Understand, right? This is the microservice applications. And coming to the monolithic applications also, when you run the Jenkins job, during that time it will create the load balancer, listeners, and Route 53. In Route 50 record will be created, and also in the Route 53 record automatically update the particular load balancer URL as well, DNS as well, everything through Terraform only. Once this is completed, okay, deployment is done, everything is done. Okay, super, very good. For both monolithic and microservices, applications are running fine. Now they will be developer will do the high level checks, and once it is done, right, will be informed to QA team. What they will do, right, they will be validate that application whether functionality is working as we expected or not. Step 25 is testing the application. So they will test the application whether all the functionalities are working or not. Everything they will be validate. Once it is done, validation is completed, it is working as we expected, then what we'll do, right? Once testing is completed, we'll be shut down the application on the AWS side. Okay. Why we are shut down the application? Once testing is completed, during our cutover plan, so we'll be up the application. During our cutover plan, we'll bring the application back up. Okay. Understand, right? Again, I'm repeating, guys. In build and test, phase 3, build, deployment and testing. Testing is completed. Again, we'll be shut down the application in the AWS side. Once you are doing that cutover plan, during the cutover plan, we'll be up the application, we'll be route the traffic from instead of going through go to on-premises, we'll be route the traffic to AWS side. Okay, that's why we always shut down the application. Okay, this part is completed. Phase 3 also completed successfully. What is the phase 4? Fine. Coming to the phase 4, final cutover to AWS, cutover plan and go live checklist. So first of all, right, schedule the cutover meeting. So based on the final discussion, cutover date will be finalized. Okay, initially once everything is done, infrastructure is completed, and also developer deployed, everything's working as we expected, and also QA team also tested everything as expected. Then finally, we'll be having the discussion. When are we going to set up the cutover plan? Okay, we'll be this cutover date will be finalized. Okay, now Scrum Master will schedule the meeting. Depends on discussion. Example, tomorrow, next Monday, we are going to be cutover plan. Then Scrum Master will be schedule the meeting. There, right, depends on the cutover plan. We may have 3 hours, 6 hours, 8 hours, depends on our application, everything, right? We'll be having the cutover plan. During that time, we'll be application, that's specific time. Okay. Once it is done, right, what we will do? Next, example, today we have a cutover plan. We are ready for that. First step, right? Stop the application on-premises. First, we need to stop the applications. After the final data sync, right? We will be stop the on-premises application. Once it is done, the reason, right? Ensure that no new transactions are being processed in the on-premises system. Once you stop, right, any application, any data, right, it won't be right because all the applications is down. Here you have to remember, in case if it is a production, right, what we will do, we'll be informed to clients. We'll be informed to clients. It means we'll be send the notification. Hey, today we are going to migrate data from on-prem to cloud. So so and so time. Okay. So they also understand, okay, this particular time the application was done. So it will be done. So they won't reach out as anything. Otherwise, if you're not sending, right, they may think like our application, our application is down. So they will send that, they will raise the tickets as well. So you'll get a lot of tickets as well. Okay, clear. So this part is clear, right? Step 27, super. Now step 28. Step 28 is we will be update the DNS records. Okay, and here you have to remember before 28, what we will do, right? We will be up the application. First thing, we will be up the application. And then we'll be update the records. Okay, modify the Route 53 record to point to the AWS load balancer endpoint. We'll be do this particular one and we'll be monitor the traffic flow, whether it is going to on-premises or AWS. It should be go to the AWS only instead of on-premises. And as I said, right, if it is the internal tool, what you have to do, you need to connect the client VPN, then or Cisco VPN, then you can able to access whether it is application accessible or not. Understand, right? So this part is clear, right? Cutover plan, what we'll do, we'll be update the DNS records and also we'll be enable the application live. Earlier we stopped, right? We'll be up the application and we'll be do that. And also we'll be monitor the traffic to the specific one. And here you have to remember, one thing, update the DNS records, right? Example, if you are migrated records to the AWS side, AWS Route 53, that is fine, well and good. Sometimes still some of the project during the migration, that records will be still exist in the on-prem only. Then what you have to do, you need to update that your load balancer in the on-premises center, on-premises record, you need to update the load balancer from existing on-premises load balancers to AWS load balancer. You need to update in the on-premises side. Okay, in case if you are using Route 53, yes, you can go ahead and modify the Route 53 directly. Understand, right? Fine. Step 28 is completed. Okay, well and good. What is that step 29? This is the one of the most important, guys. Step 29. Developers and QA team validate that application functions are as expected, working as expected. Everything's fine. And also they will be ensured that all the integrations, services, APIs are working correctly. They will be check each and everything, whether it is working as we expected or not. Even though earlier we have verified it and we have shut down the application, again, once traffic is route to that on-premises, right? We'll be do the testing. Okay. And also QA team perform the regression testing and notify all relevant teams of any issues. If you have any issues, right, they'll be informed to respective team members. Example, sometimes, right, it may issue related to DB, it may issue related to code. They'll be informed to respective team. Okay, fine. And next one, right, monitoring and stabilization. So monitor the environment few days to detect any issues. So once example, you have migrated dev environment, we'll be monitor a couple of days and we'll be from DevOps side also, we'll be having that 24/7 from both offshore and onshore. Will be support them if they have any issues related to DevOps side, example, case related one, some other thing. And also, if you have any issues, right, address and resolve issues as needed with development or DevOps teams. So if you get any issues, we'll be fix those issues. Understand that? Fine. And one thing here, in case some issues we may not be fix it immediately. So what we have to do? Rollback plan if needed. So if issues occur, attempt to fix them, or on demand. We'll be fix those issues. In case if you are not able to fix those issues, what we'll do, right? If it unresolved, we'll be roll back the DNS endpoint to on-premises infrastructure. As I said earlier, in on-premises, we'll be update that AWS load balancer DNS name. So it will be route the traffic to the AWS side. But in case if you want to be roll back, right, the particular in the on-premises, instead of updating that AWS DNS name, we'll be update that on-premises DNS name and we'll be up the application. Understand, right? So this is the we'll be do. So this usually depends on sometimes, right? Once you migration is done, everything's fine. Sometimes some issues occur. We may need to roll back. Okay, we don't have any option to immediately fix it. It may take little bit time to write the code. It may take 1 week or 2 weeks also. So during that time, right, we'll be roll back the particular one. Okay, and then once it is done, right, either it is rollback or whether it is migration is completed, we will be send the final communication to clients. Hey, we have completed migration, so applications are working as we expected. So they'll be use our application. That is the final confirmation. Okay, and here this is the one. Rollback is also plan. You need to be ready. And final one, right? Once it's everything's done. Example, we have done this particular one for dev environment. Okay, same process, everything stable in the dev environment. So we need to be replicate the same process for remaining environments as well. Test, QA, UAT, pre-prod, prod, everything. And here you have to remember one thing, guys. Cutover plant usually will be set up for production and pre-prod only. Pre-prod and production will be having that cutover plan. For the lower environments, we don't require any cutover plan. We'll be do whenever required. Depends on discussion between DevOps team and developer and QA team. They will be do that anytime. But when it comes to that production pre-prod, right? Sometimes pre-prod also we need to send the notification to clients as well, because some of the clients, they may use pre-prod URLs as well, application as well. That's why we need to inform them. Understand it? For coming to the dev, test, QA, we don't require to send any notification to clients. So that those are internal tools, right? Internal access. So we don't want to worry on that particular one. Any questions now? Any questions now? So total we have a 32 steps, okay, to do the cloud migration plan from on-premises to AWS. Remember one thing, currently majority of the organization, they may also expecting, hey, Murali, do you have experience on cloud migration part? So you have to be tell that, yes, if you have. So if you want, you can have a look this total video. Don't skip it. So please have a look 1 or 2 times so that you will get some idea. And also here, I already written each and everything in detail, so that you will get, you can refer this particular one. So same process only, 99% will be follow the same process only, guys. Just please have a look these steps one more time. If you have any doubts also, can feel free to comment so that I will try to respond as soon as possible. Understood, right? Any questions now? If you have any questions, feel free to reach out to me via LinkedIn, Instagram, Telegram. And also we have a Techworld with Murali website. In this website, I already published DevOps, AWS, Kubernetes, Terraform, AWS networking, DevOps hands-on project, Helm. Here we have a 1 month, 6 months, 1 year plans. So if you are planning to enroll, you can enroll here. And also we have a Techworld with Murali YouTube channel. You can subscribe here to get more updates. If you have still any question, feel free to comment. I will try to respond as soon as possible. And again, I'm repeating, guys, currently most of the organizations are expecting can you please explain that cloud migration process from on-premise to AWS? Example AWS. Okay, have you worked on migration part? So you have to you should be aware of this particular one. Okay. Still, if you have any question, feel free to comment. I will try to respond as soon as possible. Thanks for watching this video. We'll see you next video.